Okay, so let me give you a summary of all the proportional relationships. So here, if y is directly proportional to x, then it would be written as this. Now, when you're told that y is directly proportional to x, then inside your mind visualize these lines here. Okay, so it's going to be this kind of a relationship. So this here could be one value of k, and this line here you have another value of k, k2, k2, 3, and k4, and so on. So when you're told y is directly proportional to x, then visualize this graph, or you can you can visualize it as this as well: y equals kx. Okay, and the other thing that you have to visualize is well, if y is directly proportional to x, it's going to be this kind of a relationship. So y here, x here. If you double this, times this by 2, then you've got to times y by 2. Okay. If you times x by 3, then you've got to times y by 3 as well. If you half x, say times a half, then you've got to times y by a half as well. It's that kind of a relationship. Okay. And the other one is, hang on, this one here. If y is proportional to the square of x, so well, yeah, proportional to the square of x, it would be this. Now, when you're given this, visualize the graph. So here, I did a section on graphs where if you try and plot y equals x squared, it will look something like this. Okay, but here we're not concerned about the negative side. We are just we're just interested in the positive side. So when you're told that y is directly proportional to the square of x, then inside your mind visualize the family of lines like this. Okay, and here you have one value of k here. This is another k, and this is another k. So when given this, visualize this inside your mind. Also visualize this: y equals k over x squared. Okay, and also visualize this y and then x over here. So when you have this kind of a relationship, if you times this by 2, then you have to times this by 4. Okay, if you times this by, let's say, 3, then you have to times this by 9. Okay, so on this side it gets bigger a lot faster. If you half this, if you let's say half this, then you've got to divide. Well, if you divide this by 2, then you've got to divide this by 4, or you can think of it as timesing a half, or timesing 1 over 4. Okay, if you times this by, sorry, if you divide this by 5, which is the same as me doing this, then you've got, then on the y side you've got to times this by 1 over 25. You see, this y changes a lot more than x. Okay, and hang on. Oh yeah, and this one here, y is when y is inversely proportional to x, then you well, it would be given to you as this. And then here you've got to visualize the graph as this. It's going to be something like this. Okay, so this is y, this is x here, and I did a section on graphs where if you plot a graph of y equals 1 over x, it looks something like this, and then like this. But we're not concerned about the negative side. So it is in a way like this. Okay, hang on. So yeah. So when you get given this here, inside your mind, visualize this, and you're going to get a whole family of these lines. And yeah, you need one point on a line to determine which k you're talking about. Okay, so this line here will have one value of k. This one here will have another value of k. Well, anyway, when given this here, you can also visualize y equals k over x. And when given this here, you it's going to be this kind of relationship here. Y on x. Now, if you times this by 2, if you double x, then y will have to be halved. So it will be well, if you times this by 2, then you've got to divide this by 2, or you can visualize it as this, timesing a half. If you times x by 3, then you're going to have to times this by 1 over 3. Okay, it's that kind of a relationship. Okay, and this one here, y is inversely proportional. So yeah, inversely proportional is going to be 1 over something. Okay, inversely proportional to the square of x. Now, yeah, it's inversely proportional to the square of x. So 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 when given this here, visualize this graph inside your mind. This here is the purple line here. Hang on, the purple line here. This one here is y equals 1 over x. You see, if you get a graph plotter on the internet and try and compare how try and plot this on a graph plotter. Y equals 1 over x and y equals 1 over x squared. You see, x squared gets smaller a lot faster. You see, this here is as x increases, this is y here. You see, this black line is y equals 1 over x squared. You see, it gets smaller a lot faster. Okay, so well, play around with a graph plotter. You would then see the relationship between y equals 1 over x and y equals 1 over x squared. Okay, the black line here represents 1 over y, so y equals 1 over x squared. Well, anyway, when given this here, inside your mind visualize this graph, and also inside your mind you can also do this: y equals a constant over x squared. Now what that means is, when given this here, you can also visualize this y x here. Now if you double x times by 2, then you're going to have to times this by 1 over 4. So meaning, if you double x, then you've got to divide y by 4. It's that kind of a relationship. So if you times this by 3, then you've got to, in effect, divide this by 9, or you can visualize it as times in 1 over 9. If you times this by let's say 5, then you've got to divide it by 25, or you can think of it as times in 1 over 25. You see, a small increase in this would decrease this massively. Okay, and then if you decrease this, let's say if you halve this times a half, then you're going to times this by 4. You see, when x gets smaller, then it's then this y thing is going to get a lot bigger. Okay, and the other one is well, here you can say y is inversely proportional to the whatever here. You can say to the power of 1 million if you wanted to. So if y is inversely proportional to the cube of x, then it will look like this. Okay, and then again, get a graph plotter or go on the internet. Plot one graph of this, y equals 1 over x, and then plot y equals 1 over x squared, and then plot y equals 1 over x to the power 3, and then see how superimpose all three lines onto one graph, and then you can see the relationship between the three graphs. You see, with 1 over y to the power 3, it gets smaller a lot faster than 1 over x, and then this middle one here is 1 over x squared. You see, this black line is 1 over x to the power 3. Well, anyway, when you get given this here, inside your mind, visualize this, okay? And then also you can also visualize this. Y equals a constant over x to the power 3, okay? And what that means is, when given this here, what that means is, hang on, x here, what that means is, if you double x, meaning if you times it by 2 here, then y will get 8 times smaller. So we'll get 8 times smaller. If you times x by 3, then y will decrease by hang on, 3 times 3 times 3, so that's 9 times 3, so that's, yeah, if you times this by 3 here, then this thing here would be 20, well, you're going to have to divide y by 27, okay? It would get, if you times x by 3, then you're going to have to divide y by 27. So you see, y changes massively when you just nudge the x slightly. So if x changes small by a small amount, it affects y massively. Okay. So yeah, okay.